Welcome back. Okay, temperature. Temperature can be defined as the degree of coldness or hotness of an object. Yeah. Now we have the what? We have the SI units for measuring what? Temperature. And they are what? Kelvin, centigrade, and what? Fahrenheit. Now, Fahrenheit is being what? Named in honor of a German physicist named who? Daniel Fahrenheit. And we also have what? Method for solving temperature or for converting temperature, which are what? This F is equal to 1.8 degrees centigrade plus 30 degree. This is for converting what? Centigrade to Fahrenheit. Why this formula is for converting Fahrenheit to what? Centigrade. Okay, now let's look at what? The scale. The scale of the upper and what? Lower fixed point of what? Of those scales. Okay, we have Kelvin. Kelvin is what? 3. We have Kelvin. Kelvin is what? Its upper fixed point is about 373, while its lower fixed point is about 273. While the one of centigrade, its lower fixed point is what? Its upper is what? 100 degree, while its lower is what? 0. While its lower is 0 degree. While the one of Fahrenheit, its upper fixed point is 212. While its lower fixed point is what? 32 degree. They're all in degrees. Okay. Now we have a general formula in it. Very simple. Try to know them all. Okay. The general formula for solving what is T minus B1 is equal over what? A1 minus what? B1 is equal to T2 minus B2 over A2 minus what? B2. Now we can use this to solve any problem in what? In temperature. You can use this to solve any problem in temperature. But that was then. But now we have a new generated formula. Now the question is what is the formula? The formula is now what? Is theta degree over 100, which is equal to r theta minus r0 over what? Minus. So we can use these two formulas to solve the same thing and get the same answer. It's very simple. Okay, now let's do something. Let's solve a problem to make us understand what we're saying. Now let's look at this. Look at this question. It says here, a platinum resistance thermometer wire has a resistance of about 5 ohms at 0 degree and 5.5 ohms at 100 degree. Now calculate the temperature of the wire when the resistance is 5.2 ohms. Very simple. First of all, place the degree to know what you are doing. Okay. Now let's make it easier. Let's bring in a symbol. This is for the temperature. Here should be 100. Here is unknown, while here is 0. Now let's go for ohms. Remember they said what? 5 point at 0, which means here is now what? Okay. Now at 100 we have 5.5 ohms. Then now you're meant to find this temperature. Look for the temperature. But they said at this temperature we have what? 5.2. Now we are going to use that formula. We're going to use the formula T1 minus B1 over what? A1 minus B1 is equal to T2 minus B2 over A2 minus B2. So how do we use it? Now here it goes. T1 is for 100. T1 is for the 100. It's for the theta, the temperature we're meant to look for. It's for the temperature we're looking for, which is now theta minus what? B1 is for the low point over what? A1 is for the high temperature minus B1, which is also what? The low temperature, which is equal to T2 5.2 minus what? Minus B2 5 over what? High temperature minus low temperature. So we forge ahead, this will minus this, have theta over what? 100. This minus this will now be 0.2 over what? This minus 0.5. This times this will now have what? 0.2 bracket theta is equal to this times this 0.5. Why this is now what? 100 times 0.2. So this times it now becomes what? 0.5 theta is equal to what? 20. So if we now divide, we now have that theta is equal to 20 over 0.5. So therefore theta is equal to what? Theta is equal to what? 40 degree centigrade. That's for that one. Or you can still use the other what? Formula I told you about. Let's use the other formula I told you about. Theta over 100 is equal to r theta minus that r 100. Okay, so here we go. So we now have this to be is equal to our r theta is what? Is for that feeder, is for this side. So for this place here. Here we have our r theta here is what? This. We now have it to be what? 5.2 minus our R0 is what? Is this one. So how about 5 over what? Our R100 displays now is this. I have what? 5.5. While our R0 still remains 5. So this will now be, let's multiply this minus this. You know what it gives now? 0.2 over 0.5 times 100 times 100. So it's now what? This will now be 0.4 times what? 100. Therefore the theta you're looking for will now be 40. Therefore 40 degree centigrade. You see? So we can either use this method or this one. It's like this one is more simple. Why? Because here we don't need this man again. Just that we only know the value of this. We'll go straight by doing what? Filling in these ones there. But why for this side? You fill in both this and this, you work with the two before you get what the final answer. Okay, so let's proceed. So that's it for this one. So we will like call it a day for here. In this class, we'll now continue with thermal expansion, and there we'll now bring in some